Hello everyone, and this is a small update to my ornamental design series, and primarily I'm talking about how to adapt the old copy stamping techniques to the new for each method, because back then I was still using copy stamping. Now I have two videos on my YouTube channel. Like if you go to my YouTube channel and do a search for each, you'll get like copy stamping 1 and 2. So this is sort of an update to that same technique. Now, with the ornamental design series, I was using copy stamping to modify the L systems on a per copy basis. So we're just going to see how to do that. But what I'm going to do is something slightly different. I'm going to use like the attribute adjust float node to show you, how to go about doing that. Okay, so first thing is I'll just create an L systems. This is not a lesson on L systems, so just blindly follow whatever I'm doing. Okay, so what I'm going to do is I just want to create like a line that curves. Okay, so it's pretty simple. I'm going to create like the premise will be x, and I'll say x is equal to f plus x. So what this does is that for every generation, the plus is an angle value. The angle value is given here, like it's going to turn by 28 degrees. Okay, so every generation it just turns by 28 degrees and it keeps turning, or in this case now it's like 13 degrees. So as I keep increasing the generations, you'll see that it keeps turning. Now you get stuff here which is called angle scale and size scale. So this is the size of every branch, like every stick in the middle, and then this is for scaling it down for every branch. Okay, and then this is scaling down the angle for every branch. Okay, so the rules are pretty simple. Like the double inverted commas is for scaling. So now I can see you'll see like the distance keeps reducing for each branch, okay, by however much is the value here. And then the semicolon is for controlling the angle. Okay, so the first, like if you lower it, then the first one is like 13 degrees and then it will keep sort of getting lesser and lesser and lesser. Now what we want to do is I want to generate a bunch of copies where maybe like each copy will get either more angle or less angle, or whatever, something like that. So what I'm going to do is now you can just apply like for each iteration, but then what you need to type is very long. Okay, so it's like a detail attribute and it's like super long. You can see that in my first video, like this one will show you how to do that. I don't like doing that, okay, because I don't want to type in so much, because then as you type it in and then it's like, okay, now if I have to do like a pt num divided by num pt, then that becomes even longer. You want to do like a fit range, then it becomes like you're typing a whole goddamn novel in there. Okay, so I don't like that. Okay, so instead what I'm going to do is we're going to define the number of copies based on a line. Okay, so I'm just going to take a line. I'll copy paste this. So this has 10 points, so we'll have 10 copies. Okay, and then the only thing I want to do is I'm going to take a resample node and I'm going to calculate the curve view. Okay, so just come in here. We don't need any of this stuff. Just turn on the curve view attribute. So the curve view it just generates a ramp going from 0 to 1, interpolating between the points. Okay, so if you look at the curve view, it's mostly just that. So you can use that and then fit. So that's technically like pt num divided by num pt. Okay, now once you've done this, take a transform and just scale it down to 0. So what you have is you have all your points at 0, but they have the curve view value on them. So this is useful. So just to show you now what we can do with this, I'm going to take a transform node and I'll do a for each. So we'll do for each point. I'll put a copy to points in the middle. So this comes in here, that goes in there. This comes into the point and this comes in here. And let's just call it, I'm going to shorten the name. So I'll just call it for each B, because this is already for each A. Okay, so now let's say I want to move these copies. So that's the first thing I want to do. So what I'll do is, if you look at this video, okay, I'm more or less doing the same thing, except I was doing it in a wrangle. Now, if you don't want to do it in a wrangle, okay, like a wrangle is useful if you want to keep everything in one place. But I kind of realized like if you have like, if you just use the float node, the attribute is just float, that is equally useful because that has like a whole bunch of stuff in here. Okay, like it generates the ramp for you, you can do random, you can do noise, you can do all of that stuff. So it just makes life easier. So I'll call the attribute as move, and I'll set it to always, and we'll set it to remap attribute. And we're going to remap curve view. So this is fine. Now all I have to do is, in this transform, we want to bring this value from here to, through the copies into this. So the way to do that is using a point function. So let's say in the x, so the value is going from 0 to 1, and I want to use that to move my points or move my copies from, like the first one will be 0 and then 0.1, 0.2, 0.3, 0.4, like that. So all you do is the move attribute will be brought in over here. So just type in point, and you need like 4 things. Okay, so you need which node you want to access, then you need to know the point number, then you need to know the attribute name, and then if it's a vector, then what index are you accessing. So if it's like 0, 1, 2, but if it's a float, then it's just 0. So we want to access like do colon dot dot slash, we want to access for each b. Now since it's a for each node, it only has one point inside, so we are going to access 0, and then the attribute is called move, and since it's a float, it will be 0, and that's it, and there you go. So now this value over here controls your movement. So if I take this here, see, I can actually like move this. And the other advantage is because you have this ramp here, you can actually do some, fancier things with this. So I can just take this and see, I can like scale it down like that, or, so I can actually like move my copies and do things like those. Okay, and then you just make as many as you want. So it makes life pretty easy. So I can just do Control C, Control V. So let's say instead of P scale, I just want to do like, I want to control the scaling from here. Okay, you can do it through P scale also, but just to show you. So let's just call it shrink, because you can't use the word scale or P scale because those are like ready-made or like inbuilt attribute values. And then all you have to do is just take this, copy paste it to wherever you want, and just change the name. So this will be called shrink, and there you go. Okay, so now I can just take this and I can flip it, and maybe I can scale it down a little. And yeah, let's just take it like this. Okay, so once this is done, let's just take this and I'll get it up to like say 30. So it's like a lot of points. And now we want to start modifying, let's say, the angle scale. Okay, so I'm going to do another one. So just make as many as you want. As I said, I like this because it just gives you everything ready-made. You don't need to, you can, like if you're used to doing the wrangle node, it's fine. But if you don't want to do Vex, just do this. So I'll call it angle scale. And then just, take this, Control C, go here, Control V, just change this to angle scale. Yeah, now it goes haywire because these values are too much. So you can't go over 1, that's a bad idea. So just sort of like, yeah, like let's say this is small and then this is more. And there you go. You can do stuff like this. And then let's just say, I'll call this one as step size and do the same thing here. So Control C, Control V. Let's change this to step size. And there you go. See, so the same thing here, but we'll reverse it. So this will be longer and this will be shorter. And again, having a curve is always a good thing because you get more stuff that you can do. See, so you can do stuff like this. Or if I change this, let's say instead of remap, I make it random, so you can do that. So you can actually randomize these if you want. So you get a lot more options through this just because, the node just gives you those many values. So you can also do I guess you could do line, we'll just have to define where the line is. In this case, the line won't work because all the points are at 0, so it won't work. If you do it all, like if I take this transform and I bring it to the end, then the line will work. Because now you have a line that is going vertical. So if let's say I take this and I keep it like that, then it could work. So I can just take this, see. So now the line node is actually working. So just like do all your stuff and then just scale it down to 0 at the end. So then all your control is just coming in from, like it's not using the point position anymore, and you can just define it any which way you want. Okay, so that's pretty much it. So this is another way of doing the old copy stamping stuff through for each.